Okay, let's solve this smokestack problem. And what happens is you have a smokestack emission, which is some sort of industrial uh, magic, and it releases a lot of toxic things into a container, and we're analyzing it into a 1.25 liter tank. Here's the pressure, and these are the percentages of each of the gases. 92% CO2, 3.6% NO, 1.2% SO2, and 4.1% H2O by mass. That's a bummer. So if it was by mole, it'd be easy. This problem would be easy. Well, we'll see why in a second. What is the partial pressure exerted by each gas? Now, the partial pressure is the pressure that's given by each gas, and that really has to do with the number of moles. Because PV equals nRT, when you solve it, P equals nRT over V, and the pressure of any gas is related to the moles. It doesn't matter what moles it is, it just matters how many of that there are. If this problem said percent by moles, it would be easy because then we know that 92% of the pressure of this pressure is CO2, 3.6% NO is this. It's kind of nice, but that's not the case. It's by mass. So we need to get to moles so we can solve our problem because we need to find the partial pressure of each gas. So what we're going to do first is let's start out with imagining we had 100 grams total. You could pick any number, but this makes the math easy. So that means that 92% of CO2 is 92 grams, and then use molar mass to solve the moles. Do that for each of these yahoos. And you have the moles of each of the components of this gas. Let's divide it by the total number of moles to get the kind of mole fraction of the gas. So 0.84 is CO2, 0.098 is NO, 0.0076 is SO2, and 0.092 is H2O. So that's telling us that 1 is 100%. This is like 84% of it is CO2, and a very small percent of it are each of these other gases. So let's figure out, now that we have the mole percentages in essence, we can actually multiply it by our pressure to find out what pressure each of these gases gives. And that's exactly what we do over here. So the pressure of the CO2 is 0.84. So the mole fraction times the P total times 752, and that's 630 mmHg, millimeters mercury. NO is smaller, PSO2 is smaller, and H2O is a little bit larger. So in this particular gas, most of the pressure and most is due to most of the particles, which is CO2, and there you go.